Hello and welcome to my shop here this morning. It's the 21st of October, and yesterday I didn't post a video because yesterday I came in here to start work and boom, the lights went out, power went out. A power company had to do some kind of emergency work right in my neighborhood. Consequently, I was out of power till noon, so no video yesterday, but that gave me an interesting opportunity to listen to shortwave radios and the like with the power off in my neighborhood, in my immediate neighborhood, the 15 houses around me. And I'm almost in tears about the situation. It's just like it was when I was a kid. Holy smokes, I turned on AM radio and in my house here, no problem, tuning all across the AM band and picking up stations, and oh my god, stations from fairly far away in the United States. And this is early in the morning, like 10 o'clock in the morning. And then when the power came back on at noon, so did all the noise, of course, with it. And so my eyes, my ears are open to just really how horrid the situation is with interference noise. I mean, we know it's bad. It's really bad. Anyway, can't do anything much about that. Today I want to pursue the AVC voltage question. Is the AVC voltage correct in this radio? Is it developing the voltage it should, or is it coming up short? I think it's coming up short because it's not enough to close the eye. Why exactly it's coming up short is what I've been looking into. I've tested and replaced the tubes, which could be responsible, or I guess were responsible for a bit of a low signal, but it wasn't enough to make a big difference in the radio. So I think what I'm going to look at now is a question of the resistors that are involved in the circuit. Have some of those, or one of those, gone high, which is quite possible, and then that would reduce the voltage that's making it out to the tubes, including the magic eye. So I think maybe the first step is study up on the schematic a little bit. Okay, now the AVC, let's start with where the AVC is generated. So this tube has two diodes in it, and they're literally on the output of this transformer, and then we have the cathode here, goes to ground. It's very hard to see. They've drawn the one heater leg also tied to the chassis, which is the way all these tubes are. Every one of them's got the same arrangement. Heater to the chassis. So there's a voltage developing here via full wave rectified voltage right here, which is then fed on into the radio. Splits here, part of it heads to the switch. To get there, it goes through this resistor. So here's one that could be affecting things in some way. Comes back from the switch here, gets into the volume control, which is a megohm across the whole thing. There's another gigantic one here, 10 megs here, but that's right. I forgot totally about this tube. Oh my gosh. Okay, hold on. So there's two SQ7s in here? Holy smokes, why am I once again looking at the wrong schematic? No, I've just totally forgotten that that's how this is working. Of course it has to have an inverter to develop the 180 degree out of phase signal for the second output tube. Right, but it's got diodes. They used an SQ7 with diodes. What did they do with the diodes here? So the diode is connected and grounded. So they just grounded it out. So they just basically done away with the diodes in here. So we have two identical triodes operating, and I guess this is kind of the benefit of having the same tube used here. Okay, but that's not, I don't think it's going to have any effect whatsoever on the AVC voltage. I just fixed too many radios. I got too many bits and pieces of schematics floating around in my head here. So we come along, we repeat the thing again. This resistor. So resistors tend to go high or open. So if this went high, you'd have more and more of the signal voltage dropping here rather than across the volume control. You wouldn't be able to. It would reduce the volume of the radio. Affecting AVC. This goes high? Can't imagine it would. I think if it went low, it might, because then you'd have only 1 million here instead of 1,035,000. It's not much difference, really, is it? If you got rid of this, you still got 1 million here. So, so let's carry on. First, let's just track back from the eye over here on the grid and just be sure where it's connected. So it's connected out beyond this big resistor, which looks like it says 47, but I'm sure it's 4.7. I've never heard of a 47 megohm resistor. 4.7, that's very, very high. So the grid of the eye is getting exactly the same voltage that all these grids are getting. Here, running along here. No, there's another resistor here. But this one can't affect what's happening on the eye. The eye, so the eye, you can think of it as tapped off here. If it's already low, it has to be this resistor. We got to find this resistor. We have to find that resistor. 4.7 megohms, half watt, and it's in the middle of the circuit, near well, it's one of the outputs from here. Did they mark it, the colors, anything? Nothing. But it's look at this. So it's connected with this one. So maybe I can find either one of these. If I find this one, I'll find this one pretty quick. So that's a 35 or 50. What is that? Yeah, what is that? Holy smokes. We don't know exactly what this is. 55, 35, 38. I don't know what that is. 33. Is 33 a standard number? He says, looking at his set of resistors here. 33 is a standard resistor number, so I think this is 33. 55 is not a standard number. So it's probably 33K. So that'd be orange, orange. That'd be orange, orange, orange. That should be easy to spot this one. And this one would be yellow, purple. Yellow, purple, green, I think. Okay, let's go look for him. So it's going to be near the just 1 second here. Near the what? Near. It's going to be near the second transformer. Near the second IF transformer, which is this guy right here. So somewhere around here we're looking for that's brown, black, green. Just a ground. It's right off one of these terminals. So here's a capacitor. So there could be something inside this big fat cover here. There's another fat cover here. Could be something in there, more than just a wire. There's a big resistor. Body end dot. Yellow, brown, green. Yellow, brown. 41? That doesn't make sense. Something going on here. Something here. Look at all the orange. coming right off the terminal. Here it is. Right off the terminal, 3 oranges. Does that make sense? I'm looking back at the schematic here. Yes, it could be. Could be done like that. So that's the 333. And then it should be connected. Let's just make sure I'm reading. Yes. This end should be connected to another one. It's got to be this guy here. Oh, the paint's coming right off them. Okay, so we'll try measuring these in circuit and see what we get on them. A little voltmeter here, ohm meter, a couple of test leads. Oops, that's not the right thing. We're on the 2 meg scale there. Okay. And we're doing this in circuit. First one will be the 33K. Well, that's 33K. Okay, now we'll try the next one. This is the one I think is, oh, this is actually 4.7 megohms. So the reading's jumping all over the place. Hey, it just went open. Above 20 meg. So I'm across a resistor that's supposed to be 4.7 megohms, and it's showing a what's going on here? Did I just pop this? How did that happen? I think I found the bad actor anyway. Looks like it's just charging up a capacitor. So what I'll do is I'll nip one end of that resistor off the circuit and we'll test it for real. I think I'm on my way to bad guy here. Ooh, there's a very light wire here. You can barely, it's not light. You can barely see it. Out. What do we get now? Got my finger on it. 1.3 megohms. Is that what that just said? Something like 10. It's quite a ways from 4.7. Okay, so I'm going to replace that resistor. We're going to see what happens to this radio. Okay, just checking the value of the resistor before I put it in. Got 2 of them here, both of them measured exactly that. Yeah. They say 4.7 according to the color code. So funny that they should be exactly the same and wrong. Makes me wonder about the meter, the accuracy of my meter. But that's going to be good enough for sure. Okay, got the new resistor in there, right there. And it's in good, no shorts. Okay, let's see what happens. I think this will make a big difference. Let us see. So I still have this meter connected here. Put it on. It's measuring the AVC voltage, and we have the eye to look at too. And I think I said something about using my signal generator to fire it up, but for now let's just use the antenna. Outdoor antenna. I'm gonna have to run and switch it on. So when I switch this on, I'll take off for a moment and switch my antenna. Okay, just leave that. Be right back. Okay, nice bright green eye in there. Very good. Now, can we even see the eye very well through there? Yeah, you can actually. It's not bad at all. Okay. Let's tune. Yeah, I better put on full voltage here. Oh. Sneeze that virus right out. Okay, broadcast band. There's no movement in the eye at all. I think this is better. 50-volt scale, we're getting almost 25 volts of AVC from this noise signal. So the AVC voltage has gone up. How come the eye's not operating at all? You see nothing happening from it here. So I know it's hard to see in the camera, but you can see the bottom part of the pie there. Huh. Zero effect. Big voltage eye not responding at all, but it was responding a little bit before. Let's go on a shortwave band here. We'll try the general band. That's my that's my soldering iron. Discovered this morning that two small lights in my kitchen, sort of night lighty sort of things, or cabinet lighting systems that I've put in, just barking out radio interference like you wouldn't believe in the AM band. So I don't know if it affects me down here, but wow, that's a big lesson yesterday when the power was out. Okay, so we're on shortwave now. So if you look at that's WWV. Okay, so the bottom plate is off the radio, so the alignment may be off because of that. WWV should really be here at 10, not, I'm on this band. Wake up, Jim. What's right on 10? Thumbs up. Thumbs up on that. But look at the AVC on the meter. 15 volt scale. Is it moving at all? 5 volt scale. It's moving ever so slightly, just the width of the needle here. So it just moved a little wee bit. So I'm not going to see the eye operate with this. Ooh,
Power and
there's something worth.
Deceivableness of unrighteousness in them that perish.
This again is 9.330, which is this unbelievably powerful signal here at my location.
It's actually surprisingly
remember,
because it reveals
5 volt scale here.
will be deceived.
So what's the eye doing now?
Chapter 2, and let's start reading at verse 7. So
Tune in and out. No movement in the eye whatsoever. It's as if the eye is disconnected.
Only 2 now letters will let until he be taken out
so
of the way.
not plugged in all the way in the socket? Sure it is.
Whom the Lord shall consume with the spirit of his mouth, and shall destroy
As far as I remember on the schematic, it's just a wire that goes straight from the point at which I'm just thinking almost the point at which this meter is connected. So there's a variation in the AVC voltage, but it doesn't seem to reach the grid of this tube. Is it reaching the grid of the other tubes? Well, one way to tell would be kind of a crazy way. Turn this up.
Those who ultimately are lost will be lost because they did not take up the cross of obedience.
The cross of obedience. The cross of obedience. Okay, I could say an awful lot more, but I won't.
Answer this.
So what I'm looking for is, I'm off station, we hear the hiss. Okay, so there's the hiss. Now as I come on, the hiss should go down. Wow, this is... As this goes up. Yeah, it's hard to tell, isn't it? Brother stare. Doesn't seem right to me at all. We should be hearing shh, and then as I tune him in, his voice should replace the hiss. Radio's turned full blast to hear this. Okay, well, I'm a little hesitant to do something. I'm not exactly sure what to try next. Measure the AVC voltage on the wire that's on the connection point for the eye, and see that it's varying at that point. Almost the same as measuring it here. Okay, I've got to tip the radio up. Okay, I'm doing it. By the way, anytime you do this kind of thing, stick your fingers under the chassis. You got to be really careful that there isn't something just under there that you can touch. Especially you're going to lift a radio like this, the capacitor right there. We get this radio halfway up, get a shock, drop the radio, who knows what else is happening. Oh, that's even worse what just happened. Oh, okay, clip lead hanging in the radio. Okay, now I've got my hand on the chassis here. Use an insulated tool to shut the power off. There we go. Hand on the chassis. Shouldn't be a danger. But do I really want to be the experiment that finds out? Okay, is there a chance I cold soldered this resistor in there? I don't think it's much of a chance. Power back on. volt scale. Yeah, either side of the, oh, first of all, I should, no antenna now. Let's stick the antenna back on. Oh, I got everything off. Voltmeter, whole shot. Here. Okay, so this meter should be working again. We want to get something happening here. Why so quiet? We'll tune down to that strong thing.
And if you turn to that one, 3 for us. Okay, I've got that right here, and it says.
Now that should be producing a very, very strong AVC voltage. The voltage over here is a fraction of 1 volt. It's nothing. Either side of that resistor.
2 olive trees and the 2 candlesticks standing before the God of the earth. And if any man will hurt them, fire proceedeth out of their mouth, and devoureth their enemies. And if any man will hurt them, he must in this manner be killed.
Zero. A hard 0 on this side.
That it rain not in the days of their prophecy, and have power over waters to turn them to blood, and to smite the earth with all plagues as often as they will. Okay, let's unpack this a little bit.
No, let's not unpack that, okay? Let's see if we can take this crazy statement and turn it into something we can pretend it really means. Okay, enough of that, Jim. Now, zero on here. I think there's a good reason why that would be 0. Because it's soldered right to the chassis here. Very hard to see. No, it's not soldered to the chassis, it's shorted to the chassis. Oh my gosh, look at that. Oh my gosh, how can you get in there and see that? So there's a bare wire coming down this way, which is hard to see from my angle, my eyeball angle. It's hard to see from your angle too. This bare one's going right down there to a solder point on the chassis. It's passing right by the resistor connection, and I left a tail of wire sticking out. And the tail is this isn't on. Oh my god, this is on. Oh my god. Doesn't matter how much safety stuff you do, man, if you leave things on and don't realize it. Wow, I'm lucky I didn't get a big splash at some point here. Okay, so we're gonna, would have made an interesting video. There we go. Whoops, just thought I had a grip on it, but I didn't. Okay, she's clear. Ooh, don't stick your fingers right in there anyway. She's clear. Okay. Bend this wire back here. Out of the way. There we go. Okay, lots of clearance. No doubt about it. Okay, should we leave it up like this? No, let's put it back down. Look out, man, it's coming your way. Okay, everything's good. And we still have our AVC monitor going here. AVC volt. We'll put this back up on 50 volts full scale. That shows you I'm optimistic. Put this back on here. Volume down. Away we go. Okay, good. should have left it up and tested the voltages to see if that short was real. Sure looked real to me though. Maybe the same. And nothing's going. The eye's not going, the meter's not going. Nothing's going. This is a dead zero now. Meter not connected. We've actually got a worse situation. Different band. Broadcast band. Well, that was interesting. Whatever that noise was just started. Something started. So, look at AVC here. Extremely low. No antenna. Jim, there's no antenna. No antenna, Jim. Come on. Come on, man. How about that now? Okay, Mr. AVC voltage. Come on, do your thing. It's supposed to be going like crazy now. One thing that's different is this drops to 0. But I hardly see any AVC voltage anymore. That's right. Yep. Well, we're on the 50 volt scale. Maybe I'm being too hard on myself. 15 volt scale. That's not so bad. Yeah, that's not so bad. The noise signals are so much stronger than the broadcast signals. I can't really get a good AVC for a strong signal reading here. Okay, back to shortwave.
Prophecy that most people overlook in the gospel. It's very to blink and you miss to 17.
So I'm seeing the eye in here now is moving slightly with this.
Peter, James, and John. There he was transfigured. And when the 3 disciples looked up, they saw him standing there with Moses and Elijah. Yeah, I remember that Peter, being good old Peter, blurted out, "Hey, I've got an idea."
Good old Peter. This doesn't make sense to me. If the AVC voltage is low, the radio should be hot. And then when you tune in a signal, it may overload somewhere. This seems to be the opposite. It seems like the radio is really dead. A little bit of dirt on the tuning capacitor. This is good. Another alignment issue. No bottom plate. Don't keep forgetting, Jim. No bottom plate. May have thrown this way off. I see a reaction here, but no good signals. Okay. So for the first time we're picking up WWV on this radio at 15. I think with the plate on, I think it's over here and off scale. Okay, let's see if the AVC is doing its thing there. There is some action.
Aholisi okudum bilgan marosimda so'zga chiqqan mamlakat prezidenti Muhammad Ashrafani Afg'onistonda 1 million kishi o'zbeklar hayot kechirayotganiga ishora qilib, o'zbek tilini qo'shni O'zbekiston va Afg'oniston.
So it was requiring something like 30 volts to really drive the gain down on these tubes, and we're getting all of 15, 2 and 3 volts. Well, I have to go back and I'm seeing it here on the volume control. I gotta look at that 35,000. I did look at it, and it was correct. It was okay. I'm going to tip this radio up again. Okay. It's good. Oh, jeez.
Mamlakat kalendari asosida askar yillarda Mizon oyining 29-kuni o'zbek tili qo'shni O'zbekistonda davlat tili maqomiga ko'tarilgan kun, ya'ni 21-oktyabr bilan to'g'ri keladi. Joriy yil esa Mizon oyining 29-kuni 21-oktyabrdan bir kun oldin kelgani uchun o'zbek tili milliy kuni Afg'onistonda 10-oktyabr bilan nishonlandi.
So that's what's available right out of the IF.
Ozodlik radiosi xalqaro hayot.
That's not much. So I changed tubes, changed a few parts. Did the alignment get knocked way off? Don't have the base plate on. Let's put the base plate on and see what happens here. Let's do that. I have never considered a base plate to be that critical, but that doesn't mean that's true. Here we are. Okay, so I'm going to turn the guy off here. Holes here and these holes go so you can access those guys. So this is going on like this. It has these sides which make it, you have to drop the radio right on it. No, you know what I can do? Make this easier on me. I'll put this right on the edge here. Right on the edge. On the edge. Put this on. Almost got it. There. go. Let me stick a screw or two in it, because we want to make sure the base plate is electrically connected fairly well. One screw should do it. Enough for this anyway. Okay. Now, oh, okay. What has happened here? Okay, base plate on. What kind of difference could that have possibly made? Am I even going to be able to detect the difference? Yeah, we won't get WWV here anymore. We're not going to get it without the antenna. Seems a lot quieter. Okay, so now ion mirror, ion meter. 15 volt scale, 2-3 volts. No WWV anymore. It doesn't make that much difference. Tiny movement in the eye, tiny movement in the meter. So I think the meter and the eye are doing the same thing. This meter would suggest there's virtually no AVC voltage making it to the front end tubes. And that check I did said the output of the IF was about the same as the reading on the meter here. It's just been all around weak front end here. Let's go another band. Look at the. I just can't quite get to the strong station on this band. Some fairly good eye movement there.
Directed to website www.overcomerministry.
Overcomer. The Overcomer Ministry. With Brother Stare. He's actually quite rational at times. Contrary to what I might say about most of those sorts of broadcasters. Turned up very high for this band. So turning it up high is an indication of a weak output, say from the IF, which could be all kinds of causes. There he is again. That's full.
did have back.
Yeah, you get an idea just how much stronger this one station is. I mean, it is miles stronger, if you can measure it in miles.
Yes.
So it's an excellent tester of this. This should be going right over. This eye should be closing.
Brethren,
Barely moving.
ignorant, came to us in Asia that out of
There's two SQ7s in here. I can swap them. See what happens. Let's try that. Hey, that's a good idea. Let's swap them. I only tested one of them. Kind of forgot about the other one. Yeah, oh, it's a hot one. Okay, so it's there. Okay, I'll put the other one this one. Oh, son of a gun. Hot tubes right by the output here. Oh, that's good for him, Jim. Good thing. Well, you gotta shake them up now and then, you know, get them back in order. Ouch, 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 I touched that. 6V. 6, that is there. Come on, go in. There we go. Okay, now what about this guy? Ow, 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 ow. I just tapped that. That. Hot like heck. Oh my gosh. Hope my camera work wasn't too bad there. You know, I cannot, you know, I have to watch what the end, just like everybody, I'm watching the end of my fingers all the time. So I can't look up at the screen and take my eyes off my fingers. So sometimes you might see some bad camera work and wonder, well, what are you doing? Well, I just don't realize that's happening because I can't take my eyes off. Can't take my eyes off of you. Okay, so we swapped them. It's a bit of a tube test.
after the one you read before. In fact, thinking about it, go back and read that again. Let's get this into context. I want everyone listening to notice that although Paul acknowledges being in utter despair, he didn't stay and wallow in it.
Well, no dramatic change here.
Let's see what happens.
The eye is moving just a couple of degrees, just enough that you can see the movement, kind of like this. So still something is wrong in the I'm sure something's wrong, and if anything it's getting worse as I work on it. Hard to know absolutely for sure how these were really intended to work, what kind of voltages we're supposed to develop. Could this be okay? Now I put the bottom plate back on, and this band didn't come back to life. Or did it? If you pay no attention to the AVC, the radio seems to be working pretty good. Of course, I got the volume up full. So that's just. Now this sounds more normal. You hear the rush in it right away. Volume almost all the way down.
Is Antichrist. And there's your apostle.
The Antichrist. Oh, fun listening to. What am I going to do about this now? Oh my gosh, I get back to going over the whole thing again. In terms of alignment. I don't get it. Very, very powerful signal. Very little AVC. I don't get it. I don't get it. You don't get it. Something more seriously wrong in the radio? I don't know. This might be it for this video because it's getting a little long here. I think I gotta come up with a theory here on what could be doing this, or is there anything doing? Thanks a lot for watching. The continuing mystery.